let's make bigger practice. We have a program that have a lot of logic, but the logic is given for us in an even if condition style. You will read an integer n. If the number is even, you will print the last digit of it. For example, 234 is an even number, so we print the last digit, which is 4. Otherwise, if the number is odd, we do one of the following conditions. If the number is less than 1000, we print the last 2 digits. For example, 157 is odd and is less than 1000. We print the last 2 digits, which are 57. If the number is greater than 1000 but less than 1 million, we print the last 4 digits. For example, here, if we have such a big number but less than 1 million, we print the last 4 digits. Otherwise, we print the negative of the value. So if this is such a value here, we print the negative value of it. I would like you to stop the video, try to code it, and think about the different test cases that you need to make sure you have a good coverage for testing. One advantage and one skill for every engineer is to be a good tester for his code. So let's proceed with the code. Remember that mod 2 can help us to know if the number is even or not. So we start here by defining a symbol, by assigning a symbol variable boolean if number mod 2 equal 0 or not. So now we will know if the number is even or not. We definitely can remove it and put it here directly. So now if the number is even, we print the number mod 10 directly. Remember, mod 10 can get for us the last digit of a number. Now if the number isn't even, we have 3 conditions. If number is less than 1000, or if the number is between 1000 and less than 1 million, otherwise. For the first condition, if number is less than 1000, we need to print the last 2 digits. So the last digit can be found by number mod 100. Else if, and I would like to say if number is between 1000, greater than 1000, greater than or equal, this intended was to be greater than or equal, okay? If the number is greater than or equal 1000 or less than this number. Notice here, I didn't need to put the condition of the number here over 1000 because it is already satisfied. Like someone will say, else if number is, if 1000 is less than or equal number or less than 1 million. We can do that, but it is useless. This if condition already covered the first part, so we only need to care about this second part. Otherwise, we just print the negative of the number. Okay, let's move to another program. You will read an integer. If the number is less than 10,000, you print the number is small. Otherwise, you are to sum the last 3 digits of the number. If the sum is odd, print that this is a great number. Otherwise, if the sum is even, if any digit of the last 3 digits is odd, print this is a good number. Otherwise, print this is a bad number. So overall, you make a condition on the length first, then you make some conditions based on the last 3 digits of the number. Their sum is odd, their sum is even, or any one of them is odd, otherwise. So again, write your own code, think about different test cases for that. So here is the code. We first start by checking if the number is less than 10,000. If this is the case, we go directly here. The easiest way to handle the meaning of the logic is to get the digits first. So remember that when we take a number mod 10, we can get the last digit. And then if we did integer division by 10, we remove the last digit. So my logic here is get the last digit, remove it, get the last digit, remove it, get the last digit, remove it. This way, the digit 1, digit 2, digit 3 will have the last 3 digits. Now our first condition is about the summation of the digits. So let's define a sum here, which is the sum of the last 3 digits. And now if the sum isn't equal to 0, which means it's odd, we can handle the case here. Otherwise, we have to check if any of the digits is odd. So I'm going to make 3 variables here. If the first is odd, if the second is odd, if the third is odd. And then I'm making if condition. If any one of them is odd, print this is a good number. Otherwise, print the last statement, which is a bad number. These are my test cases, different test cases. I developed them to make sure I am testing every possible scenario that I have to To be a good tester, you need your code, you need your test cases to get inside every flow. So we need some test case to go in this flow, and we need another test case to go in this flow. And it seems here we need one test case to go here, and another test case to go here, and another test case to go here. So a good test cases coverage is a coverage that will get in every single line of your code, so that you make sure every single line of code is really correct. That's all.